Hello, I am Ajiboye Isaac, and this is a lesson series on probability laws and probability distribution. Before we proceed to the next example, it is important we understudy these important probability identities. It will be applied in the example we would consider next. So this general rule for cumulative distribution function, it can be used to determine exact individual value, probability value. For example, in the example one, P of X equal to 5. Let me mention that you can pause this video to understudy these important identities so that you can then understand by the time we start making applications. So let's take a look at this example. Given that X is a normally distributed random variable with a mean of 55 and standard deviation of 15, find the following probabilities. The probability of X taking a value less than 35, the probability of X taking a value between 35 and 60, 35 and 60 exclusive, X taking a value greater than 60. Of course, for a normal probability distribution, what we usually do is to standardize, because that is what we can obtain in the statistical table. So one way to standardize is probability of X less than or equals to X is equivalent to probability of Z less than or equals to small letter z, where z is defined as the x minus mu over sigma. Our mu is the mean and our sigma is the standard deviation following the conventional notation. In this question, our mu has been given as 55, mean 55, and our standard deviation has been given as 15. So if we therefore apply our understanding of the identities here in the question one, probability of x less than 35 is equivalent to probability of z less than or equals to 35 minus 55 over 15. When we do that computation, we have probability of z less than or equals to minus 1.33. And if you check in your statistical table of standard normal distribution, you see that the value would be equivalent to 0.01918. For Roman figure 2, probability of x taking a value between 35 and 60 exclusive will be equivalent to probability of x less than or equals to 60 minus probability of x less than or equals to 35. If we standardize, we would have probability of z less than or equals to 60 minus 55 over 15 minus probability of z less than or equals to 35 minus 55 over 15. So that will give us probability of z less than or equals to 0.33 minus probability of z less than or equals to minus 1.33. If you check the statistical table for standard normal distribution values, we'll see our value for probability of z less than or equals to 0.33 to be equivalent to 0.6293, and probability of z less than or equals to minus 1.33 to be equivalent to 0.0918. If we substitute those values appropriately and we subtract, this value will give us 0.5375. So the probability of x taking a value between 35 and 60 is equivalent to 0.5375. And also for Roman figure 3 question, probability of x greater than 60 can be interpreted as a complement probability. Now this will be equivalent to 1 minus probability of x less than or equals to 60, which is equal to 1 minus probability of z less than or equals to 60 minus 55 over 15 by standardization method. And we have already gotten that value earlier. So this will eventually now give us 1 minus 0.6293, which is, when you subtract or compute properly, you should get 0.3707. You can pause this video in the course of the explanation to understudy, to verify those values, and to also try and change those values and see what you get in your attempt. So more examples are coming up in the next videos. Like the video if it has been helpful, subscribe to the channel for more videos, and also share with those this video might be helpful to. Thank you, and see you in another video. Bye.